All right, good afternoon, everyone. Any questions?
I do, but I don't have to remember what they were.
Okay, well, I'll give you another chance in a few minutes. So what I want to do today is to go over the basic ideas behind implementing our own classes with the view of making sure that everyone can do the next homework assignment. So a lot of people have been struggling with the homework assignment, and that's not surprising that it was a challenging assignment, and it raced way ahead of what we had been covering so far. So my hope was that people have submitted some more or less reasonable drafts, and that everyone's brain is now primed to receive the information that I'm about to impart. We're going to go through two examples in today's lecture for building our own classes. The first one seems a little pointless maybe, but it's the simplest example that I could come up with that shows how a class functions internally. So the purpose of the first example is not really to automate this tally counter, but just to show how the syntax looks for instance fields and for methods, so that we can then move on to the more challenging examples. So we want to simulate, in this example, this counter, this device where every time you click on it, it advances by 1. So over here I have some piece of code that you might find in a tester. Where I'm making or constructing an object of type counter, and I call it tally. I call the only method that this thing has called count twice, and then I call the get value method. So this counter has three features. It has a constructor, it has a count method, and it has a get value method. And those one would need to implement when one writes the counter class. So let me say a word about the tester. Many people were confused about the difference between the class that's being constructed and the tester. So we had, for example, the cash register and the cash register tester, or the balloon and the balloon tester. Let me look at the balloon first, because that was kind of simple. So your job is to write this balloon class. So you write that, and then there was a balloon tester, and you will give that. And that's a common setup that we're going to be doing many times. I will give you the tester, because you can kind of tell from the tester what it is that you need to fill it. Now, a couple of technical things. I've seen a couple people in BlueJ, they were confused where they should put those two classes. These two classes must go inside the same project. Because the tester class needs the class that's being tested. So if you try to put them into two different projects, then BlueJ won't make it compile because it can't find the other one. It cannot look across projects. Now, which of these two classes has a main method? Balloon or balloon tester? Or both, or neither?
Balloon tester has a main?
That's exactly right. So balloon tester has the main method.
Because the balloon tester is the one that's actually showing the result, or returning a result from balloon.
That's exactly right. So the flow of control is main starts, and it starts in the tester. The tester makes one or more objects of the class that's being tested. The tester calls one or more methods. The tester prints something out so that we can see it does the right thing. And all of that happens in main. Should the balloon have a main class?
It doesn't need one.
It doesn't need one, and it actually should not have one, because it conceptually doesn't really make a lot of sense. That if you have like 5 balloons, you know, why have that main method sitting in there? So conceptually, balloon shouldn't have a main method. Balloon tester does need to have a main method, and that's the only method that the tester needs to have. Whereas balloon had, how many methods does balloon need? many methods does balloon need?
One.
Two. Do I hear three? Sold for two to the gentleman in the back. So it's two methods, and the reason is simply that in the tester I asked for two methods. I tested inflate and get volume, and that's what we need. So let's go back to our tally counter here. It also needs two methods, and the methods are count and get value. So now let's move on to implementing the counter. I want to have the whole thing. Okay, they're not giving me the whole thing. So I want to look at the count method here. So when the count method is called, it needs to somehow do something in the inside of the object to increment the thing that keeps track of how many times the thing was clicked, kind of the variable that's like the display. So here's the count method, and when we look at the architecture of a method, they all look the same way. They all start out with public. It turns out all the methods that we would ever want to write are there for the public. There are such things as private methods, but we won't see them for a good time. Then count is a method, and you can see it return. It takes no parameter. What does the void mean?
No parameter. I mean no.
No return value. That's right. And so over here it increments the value. So we need to figure out where's the value declared. And that's declared in what's called an instance variable. I'll just show you on the slide. So this is a variable that sits inside the counter class. Every time that your objects want to remember something, you need to have one or more instance variables for this. The counter needs to remember how often it was clicked. The bank account that we're going to discuss in a minute will remember the balance of the bank account. Now, what does the balloon have to remember? That's a possibility. But if you look at how the balloon was defined, when you call inflate, you change the radius, which may not make so much sense. You don't blow in a constant amount of things. The inflate, it changes the radius from 0 to 2, from 2 to 4, from 4 to 6, whatever. So what does the balloon need to remember for sure? What does the balloon need to remember?
Radius.
The radius, that's right. Because we inflate the radius ever so often. The inflate method says by how much we're inflating the radius, and it kind of needs to remember how much was the radius before calling inflate, so that it can compute the new radius after calling inflate. Because in the inflate method, we're not giving it the old radius, we're just saying inflated by 2 inches. What's the type of the radius?
Double.
Double, yeah.
Wait, I forgot. When it's a double type, what does that mean for double? Is that just?
It is a double precision floating point number.
So that just has to do with what type of number it is?
Yeah. And the only two choices you have is int and double, really.
Yeah.
So if it should have a fractional part, which I think for a radius, you could increase the radius for 1.5 inches, why not? Just make it double. Here for the tally counter, the counter can never be fractional. I guess if you kind of click it halfway and it's halfway in between, it could, but we're not modeling that. Because every time that we don't have like a half count, we only have count. So that's it.
So, but if you wanted like a half count for whatever reason,
You
would
could
use-
make it a double.
Okay.
Yeah. As you'll see in the next chapter when we do some amount of numerical work, the trouble with double is you sometimes get roundup errors. So you don't want to choose a double unless there's a good reason for it. But hey, for this, if you choose a double and you get a roundup error, it's no big deal. All right, so that's for the balloon, and we'll get to the cash register a little later. So these things are called instance variable. Why instance and why variable? Variable is pretty clear. It's something that can change. When I call count, then value goes up by 1 because it says value equals value plus 1 in the method. And so it's a variable. It varies. Instance variable is because you can have any number of counters, each of which has its own variable. Get to that picture. Here. So I could have two different variables of type counter. Here I have a concert counter and a boarding counter, and each of them has its own variable sitting inside. So one calls this an instance of the counter class. This is another instance of the counter class, and each of them has its own variable, hence the name, instance variable for these guys. Oh. You use the instance variables in the methods. So this class has two methods. The first one here takes value and increments it by 1. And that's the Java code for it. You just kind of have to, I mean, it seems pretty obvious. Value plus 1 is 1 more than I had before, and now I stuff it back into value. We're going to go into more detail about this in chapter 4, but I think right now it's, you can use this pattern and follow it. Later on in the bank account, we're going to be seeing things where you say balance equals balance plus amount. Then you have to think about what does the inflate method have to do. It needs to increase the radius by a given amount, and it's going to be the same structure. Now, this thing here is a mutator method. It changes what the object has internally. This one here is an accessor method. It just reports some property about the object. This one is particularly boring. It reports just the value. It doesn't make any change to it. Now, if we contrast that with the balloon, so we talked before, we have a radius, and there's a get volume method. So what should the get volume method return? How do you get the volume? Yes. So what is it? 4 times pi, whatever it is. So the get volume method would compute the volume from the radius. So the balloon remembers its radius, but every time you ask for the volume, it would just compute it. If you ask for the volume twice, it'll just compute it twice. So. Now, someone said maybe the balloon should store its volume, but I don't think there's a great reason for it to store the volume. Generally, you kind of try to store the minimum information necessary to compute everything inside. So yes, it could store the volume, but then you would have to recompute it every time that someone inflates it. So this tends to be the easiest set. So the other method that's in the balloon class is the inflate method. And so I trust that you can figure out the inflate method from what we're doing today. And that's going to take care of the balloon class. So it's actually a fairly simple class. What I assumed what you guys were going to do by today is that you had coded it up so that all the methods just return 0. That's always a good start. That way you can see it compiles and it runs and the tester works. But then, of course, over time you have to replace the 0 with the actual values. And I think that you now have a good amount of information for that. All right, let's move on to the bank account where things are more interesting. And I'll leave it to you to kind of read through the benefits of encapsulation. They don't really get they're not all that plausible the first few times you go through this, and I'll definitely come back to it later. So now the reason we want to do the bank account is it's kind of the first object that has a bunch of methods. It has internal state. It's kind of interesting. It's more or less plausible why one would want to do this. So we're going to go through the entire process of designing this class. So what we want from a bank account is, we want to deposit money, we want to withdraw money, we want to find out how much money we have, which is just about everything that your bank account does in real life, except your account might also accumulate some interest, and you might have to pay fees, and we're going to model both of those things in the lab. So for right now, we're just doing these 3 things. So we need these 3 methods. And so it's kind of a good idea when you to look at how are these methods going to be used. How would one be able to write a tester? How might they be used in a realistic environment? And so I have that over here. You can call on a particular bank account. Here's the bank account Harry's checking. You can deposit $2,000. You can withdraw $500. And then you can ask how much money is still in there. So here you have the deposit method, the withdraw method, and the get balance method. Notice that the deposit and withdraw method, they each have a parameter. The get balance doesn't have a parameter. You don't need to know anything else to ask how much money is it. And so this is called the public interface. We want to make a class that has these methods. So now we need to implement them. Or we first need to specify them. So the fully specify method, you put the word public here, because you always started out with public. You put the name of the method. Before that, you put the return type for a mutator method that tends to be void. And then here you describe the parameter. We have a single parameter here. It's called amount, and its type is double. So you've seen these descriptions in the previous chapter where you used someone else's class, and now your job is to start writing them yourself so that other people or you yourself can consume this class. So when we do that with all the methods, we end up with an outline. Okay, I don't want to have the constructor. We end up with this outline here. You have the name of the class, bank account here. You have a constructor. Here we actually have 2, which is a bit unusual. I just want to show off that you can. And over here we have deposit, withdraw, and get balance. Notice that the method bodies that actually do the work, they're empty right now. But that is how one does the first stage of design. you put out the methods with the correct parameters and the correct return value, and you leave the method empty so that we'll just fill it in later. So this particular class is supposed to have two constructors. I believe that both of the classes in the homework assignments have only a single constructor, so I'm not going to talk about constructors today. If you have a single constructor, that tends to look just like this. It's a constructor that takes no arguments. And again, we'll leave the body empty for right this minute. So now, if you wanted to turn this thing in as a tester, sorry, not as a tester, but as a partial solution, you're 90% there. There's just one little hitch. If you put it, if you submit this here, it won't compile. There's one compiler error. So look at this thing. Be the Java compiler. Where is it going to complain?
You don't have a main method.
Oh, it's not going to complain about that. You don't have to have a main method. Most classes don't have a main method. Any class that's used as a building block for something larger isn't going to have a main method. So let's look at the deposit method, for example. It says public void deposit takes a parameter called amount of type double, and the method body is empty. This has a comment in it. Is the compiler happy? Is the compiler say, "I've got to do some work in there"? No, the compiler doesn't care. There's no rule that you're violating here. The compiler doesn't understand what a deposit means anyway. Or maybe the compiler has seen a bank like this, where when you deposit your money, nothing happens. So this is perfectly legal. Same thing with withdrawal. It says a void. It doesn't return anything. It takes an amount. You're ignoring it, but it's legal. How about get balance? Takes no parameter, but it promises to return a double. What does it return? Nothing, right? There's no return statement in here, and so we have to return something. What should we return? Okay, let's try it. So we're still working on the draft here. Now it's not going to compile. Why not? Exactly. There's no balance yet. We're not even at that point, so let's not do that. Let's just return 42. Now it'll compile. And if one runs a tester, it'll turn out no matter how much money you deposit or withdraw, your balance is always going to be $42. But hey, that's good enough for a draft. So in this initial draft, we now have achieved in coming up with a class that has the correct interface. It just doesn't yet have the right behavior. But we've broken down the task. We've already produced the right interface. So with the balloon, if you make it so that get volume always returns 0, that was good enough for today. No, for Wednesday, of course, we'll want to tweak the behavior. So let's move to how do we actually get the correct behavior. So as someone said, that indeed we do want to at some point store things in a balance. So we can put that up here. Then I'm not going to worry about this constructor here for now. Then over here, this constructor, I need to set the balance to 0. So that when the bank account is first opened, it starts out with $0, as most bank accounts would. We're not modeling the free toaster. So in the deposit, I increment the balance. In the withdraw, I decrement it. And in get balance, I need to return the current balance. And that's my implementation. So with that, I would be perfectly done with the bank account. The next step then to do is to supply a tester, and we'll just look at one because it's given to us. And we'll deal with the comments next time. Tester. Alright, so here's the tester. So notice it's a separate class. It has a main method and no other methods. Its job is to test the bank account. How does it do it? It makes an object of type bank account with a constructor. It calls a method. It calls another method. It calls an accessor to find out what's now happening in the object. So it's just like the rectangle tester that you saw last time. And it finally, and that's also important for a tester, it prints what it expects. And let's see, why did we expect this? We had a new bank account, had $0 in it, we deposit $2,000, we withdraw $500, so we do expect to have $1,500 in there. And we just want to verify. So every tester kind of looks like that. Make an object, change the object a bit, find out how you changed it, and also print what you expected. So with the balloon, I gave you the tester, and so I inflated the balloon by 2 inches, and I think by another 2 inches or something, and then I printed out expected, and then there was this really weird number. How did I get that number? Yeah?
Well, I found volume after you inflated 2 inches.
But I had to implement the tester before I ran the program. So how did I get that particular number? I used a pocket calculator and figured it out by hand. So I actually laboriously figured out a couple of volumes by hand. And then I put it in. That's just how it gets us. Here the math was very easy, but sometimes for these testers the math is a little harder. All right. I don't want any of this. Now, for some reason, I don't have slides about this. So let me just project the book real quick here. No. I was trying to give a hint for the cash register thing to look at this how to, and I'm afraid I may have given the wrong page numbers because I might have given the page numbers from the big Java book. They're a little off. So to deal with the cash register, I'd like you to read through this how to that kind of walks you through the various steps on how to implement a class. So it starts out with the methods, And then, so this particular cash register, as you'll find out when you read through it, one can add a new item to it. I always find it easier to look at the code. Here we record a purchase of $29.95, another purchase, and a payment, and then we call give change, and then stuff happens. So it now walks you through how it builds up the solution by coming up with the public interface with all of the naked methods that you see here. It then figures out what instance variables we need. It turns out this class needs 2 instance variables. And here they are. And then the various methods. And then it ends up here with the tester. The code for this tester and the code for the cash register are with the book code. And so when you do the enhancement of that cash register for, what is it, P3.5, whatever that homework assignment is, you should definitely start out with the existing code. You should not try to retype that from scratch or reinvent it from scratch. So you should definitely take what's there and enhance it. And the enhancement is not particularly complicated. What your job is now, first of all, once you understand how this cash register does a single purchase, then you need to figure out how can it keep track of all of the purchases on a given day. Now, the single purchase gets erased at the end of each purchase so that the next one starts again from 0, because customers would not enjoy it if you'd have to pay not only for your things but also from the previous one. So you need to also, in a separate variable, keep track of the total of the entire day. So you'll need a new instance variable for that. And then, of course, you need to implement the methods. So that one is going to be a more challenging assignment because you didn't have much of a chance to write a good tester, and you need to really think through how does this existing cash register works. All right, so this afternoon, read through this how-to before you try to make any more work on the cash register. Try to understand how this class is put together, and if you have any question about it, put it on the discussion board. I realize this is a challenging assignment. It's generally, there's 2 spots in this class where people have a rough time. This is the first one, where just about everyone says, gosh, I don't understand what's a class, I don't understand what's a tester, I don't understand what's main, I don't understand what's a constructor, what's a method, what's an instance variable. There's all of this new stuff, and it kind of has to all, at some point, meld in your brain into something useful. And there's no painless way of really getting into that. There may be one, but it's so slow that we don't really have the time. They're making me cover so much stuff in one semester that I don't have the time to gently walk you through each of these things. It is a lot of machinery, and you just have to kind of kick it from different places and see it all together and try to get a good feeling for it all. So the hope is that you now have an intuitive feeling for what an object should be, but now you have to implement your own, and so you have to put all of this machinery in there. All right, so this how-to though is your friend. Be sure to read through it carefully. All right, now we're ready for a lab. So in the first, and we're only going to do part A today. In part A, you need to enhance an existing class. So you need to enhance the bank account class and add some features to it. And so the feature that I want to do is that you keep track of a transaction fee. So this particular bank will charge a transaction fee of $1 for every deposit and for every withdrawal. Whether or not it's fair to charge for deposits, we're not going to argue. This is how the National Bank of Java operates. Okay? And mercifully, they don't charge for just checking out the balance. Although I wouldn't put it past them to start doing that soon. So you need to keep track of those fees, and at the end of the month, the fee gets deducted. So the fee doesn't get deducted like right away. It gets deducted when prints the statement at the end of the month. And that's not totally uncommon. I mean, some banks really do operate like that. Oftentimes what they do is they give you like 5 transactions for free, and then from the 6th on and so on they charge you. And some banks do in fact deduct that at the end of the year. So here I've written a tester that should work with your code. So let's have a look here. So we're depositing 2,000, we're withdrawing 500, and at this point the expected outcome is 1,500. No fees have yet been charged. Now I'm calling the end of month routine. So I'm assuming this now is the end of the month, statements get printed, and now the fees get deducted. Notice that now it's $14.98. Why $2? Because we had one deposit and one withdrawal, each of which cost $1. So then we're depositing and withdrawing more, and now it's down to $19.96. So again, there is a $4 total deduction, $2 in the first month, $2 in the second month. So that's the behavior that you should emulate. Now how the heck are you going to do this? You're going to have to figure out how to keep track of these fees, and you're going to need an extra variable. The reason you need an extra variable is that the deduction doesn't happen right away. That some number of deposits and withdrawals happen, and that must accumulate in some extra hidden variable what is happening, and only in the end of month does it actually get applied. All right, that is your task to do. And if you have extra time, I've put in a second challenge here, and these little crowns there, that means they're optional. So if you get there, that's great, and if not, don't feel bad about it. You don't have to do it. But I just want to make sure that no one is bored.